All right. Of course, I picked the one time that the announcement comes on, but welcome everyone. I appreciate you joining us today. Just so that you are aware, I am bringing this to you from the exotic location of the airport. So I will apologize if there's any announcements or anything that supersede that, but we will definitely dive into this. So the intent of this series that we've put together for you is to do kind of a deep dive into what the compliance paths are, focusing on what that means as the 2024 IECC is starting to go through the process of being adopted. So today we're going to take a look at our prescriptive paths and what that means for us with the 2024. Always feel free to either raise your hand or to place a question within the chat, and we will definitely get those all answered for you. All right. So when we talk about the compliance path, there are a couple of things. Of course, we have 105.2, which was previously section 103.2 that said, hey, the compliance path has to be listed on the plans. But what exactly are our options when it comes to the compliance path? So if we go into R401.2, this is really that section that tells us, hey, you need to comply with one of the following. And our choices are, R401.2.1 all the way through R401.2.4. But what we're going to really focus on today is going to be that 401.2.1. And this is our prescriptive path. It's probably the path that everybody is very familiar with. Everybody calls out prescriptive. And sometimes I think there's a little lost information that happens by just calling everything prescriptive. So there we go. So after we've figured out which compliance path prescriptive, if we go into this actual section of R401.2.1, which if we came to the application, right, it says follow one of the following. We picked 401.2.1. It says that when you choose this particular option, you're going to comply with the requirements that are found in R401 through R404, and you will also have to comply with section R408. Now we'll dive into kind of a high overcast of what all of these are pertaining to. But the first thing we truly need to understand is when we say that there is a prescriptive path, we have to understand that that really does entail a lot more than just saying that it's prescriptive, because it truly goes beyond that. Now that one says 21, but it should say 24. And the first option when we have this prescriptive path is choosing to go with that installation and fenestration criteria. Now you'll remember that back in the 2021 edition, the installation and fenestration criteria prior to that had always been that R value option. In the 21, it switched so that the installation and fenestration criteria option of the path is actually that U factor, F factor option. Now on the 24, it does stay the same. So the installation fenestration criteria is referring to that U factor option. Now our second one is our R value alternative. Probably when we say prescriptive, it's very recognizable to us. And this is the one that many, many people think about when you say, I'm going prescriptive. Now, your third option is the total UA alternative. Now, what you see on the screen here is for if you were going with the 2021. If we look at what this prescriptive path is for the 2024, you'll notice there are some slight changes. Now our insulation and fenestration criteria is still the same, still using that U factor, but it's now including U factor and F factor for it. It also has the second one, which is that R value alternative. And then the third option is no longer that total UA alternative. It's actually referred to as the component performance alternative, which is typically thought of as res check. That's a pretty, I guess, kind of slang term for it, if you want to think about it in that fashion. But the component performance alternative, you can use ResCheck for it, which is a free software, but there's other software programs out there that can be utilized to demonstrate compliance with this particular compliance path. So let's dive in really into this first one. Now, the first one is the insulation and fenestration option. Now, this is basically, you're kind of doing everything by the book. You're going to be required to demonstrate that your assemblies, because this is based off an assembly approach, is you're going to, depending on what assembly you're trying to demonstrate, you're going to show that it complies with the U factor or it complies with the F factor. You're going to utilize table R402.1.2 that gives you that number that you cannot exceed, right? So that's the worst that you can do, is the numbers that we'll see in the table. And then in the past, I would say that this approach has not been utilized all that often. And the reason it hasn't been utilized all that often is there is a lot of work that's involved with it. And there really isn't a software out there that does it for you in this fashion. So if we took a look at the table, this is the new table. And in the 24, you'll notice the design of the table has changed too. And honestly, I kind of like this version of it a lot better. It does kind of similarly represent what you would see on the commercial side, where the components are on the left-hand side and the climate zones are up at top, where in the past editions they were swapped, right? The climate zones were on the left-hand side and the components were up at the top. I guess for a teaching aspect, I like it because the table fits much nicer in this fashion than they have in the past. But most of the concepts in here are really the same that you have seen, you know, all the time. You have your fenestration, you've got walls, you've got crawl spaces, slabs. The one thing I will say that has changed is the fact that now there is a row that is dedicated entirely to the concept of that insulation entirely above roof deck. Now, while we're talking about the residential side of things, we do have to remember that our 2s, our 3s, and our 4s that are 3 stories or less have to follow these particular provisions. So while you might not find in Colorado a lot of insulation entirely above the roof deck, as far as quote unquote single family homes or even townhomes, when you start looking beyond those single family homes, that's when you're going to see insulation entirely above roof deck. And if we went to our neighboring state in New Mexico, a lot of their roof insulation is actually insulation above roof deck. So this was a good addition to the code. Now, what I want to talk about is how exactly this particular option works. Now, this is, again, that assembly approach. So you're taking components of that assembly, whether we're going to pretend we're talking about a wall here. And so you're going to take that wall and you're going to add all the various components together: insulation, studs, sheathing, drywall, all of that. And you're going to end up with a U factor at the end of all the equations. And remember, when we talk about U factor, if we want it to be better, it has to be lower. So the lower the number for the U factor means that it's a better energy efficient assembly. So here's how we're going to take a look at this. Here is an example of a wall, and you'll see that we got the order of it is from the outside: air film, plywood siding, 1.5 inch rigid insulation, 1/2 inch wood sheathing, an R13 batt insulation, it's chipboard, and air film. Now, when they're talking about air film, that's typically a paint or something of that nature for it. It's not necessarily the like some people say the plastic in the walls. That's not the air film that they're referring to. So in this concept, you're going to have two columns. You're going to have one column that's going to have the various components that we just saw on this screen, the design of this assembly, and you're going to have two values. You're going to have a value of where you would get this when it's located at the cavity, where the insulation is going to be, and then where the R value is, where the value will be when it's at the stud. So if we look at this, we see our air film in a 2x6 wall. We're going, air film is 0.17. We got our siding is going to give us 0.59. We've got our 1.5 inch rigid, which gives us 7.5. Then we have our 1/2 inch wood. That's giving our wood sheathing. That's giving us our 0.81. Then we have our batt insulation. This is the location that we're going to find these differences. And the difference is because when we have that R13 in the cavity, we have insulation and that R value is an R13. Now, when we go to where the wood is, there's no insulation of that wood. It is just a wood stud. And typically, wood studs get about 1 point, I think it is, 1.12-ish, somewhere around there, of an R value per inch. So you'll notice there is quite a significant difference there. Almost half of what we have with that batt insulation is what we get at the stud. So if that were to be an R30 in that wall, you're going to have 30, and then you have the 6.88, 30, 6.88. And then we have our chipboard, which again, they're both at 0.45, and our air film, which is 0.68, because there's no difference that differentiates it from where the cavity insulation is and where the stud insulation is. So when you add all of those up, the two columns, you end up with our R value assembly for at the cavity of a 23.2, and then our R value at the stud is actually going to be a 17.08. So you can see that there's a difference. Now, the other thing that we have to keep in mind is we have to know what the framing factor is. And when we are talking about conventional framing, the typical framing factor is about 25%. And what that is indicating is for a wall, about 25% of that wall is not insulation. It's actually going to be wood. And so framing factors for conventional, like I said, is about 25. If you were to do light frame construction, you're looking at a framing factor of about 16 to 18%. So that's a pretty significant difference about the amount of insulation you get for light frame construction and what is considered the conventional frame construction of the 25%. So now this is the compliance path that math, if you love math, this is the compliance path for you. That's all I got to say. So now what we're going to do is we're going to take our value right here, and this is our insulation or our R value at the cavity, the insulation part. And so we know that our framing factor is 25. So that means we have 75% of the wall is going to be a cavity space. So we're going to take 75% and multiply it by the 23.2. That gives us ultimately 17.4 when you do this equation. Then we're going to jump on over to where the R value at the stud is. We know that the framing factor is 25%. So we're going to multiply 0.25 by the 17.08, and that equates to 4.27. Now, if we add 17.4 and 4.27, we end up with 21.67. Now, this is all the 21.67 for our wall assembly is the R value for it. And in this particular instance, we're looking for that U factor. So now we have to take that R value and do the inverse equation for it. So we're taking 1 divided by 21.67, which is the value that we got when we did our math. And ultimately, that gives us the U factor of 0.46. So if we take that number and we go look at the table, does 0.046 meet the requirement as far as an above grade wall assembly? All right, good job, Athena. The answer is no, because our number is 0.046. The maximum number we can have per what the table tells us is 0.45. So our number exceeds that. So we would have to then go back into the design and alter it. Good job. Gold star to you, Athena. All right. So kind of wrapping this all up so that it's in a nice, pretty package. So how this would look is the sheer fact that now what we're doing with this particular compliance path, you are going by the book and you are not performing any trade-off whatsoever. Whatever that book tells you to do is what you're going to do, and everything at that point then has to be placed on the plans. The only type of quote unquote report that you would need to provide for this is really documentation of what the assembly values are and where you got those assembly values. Now, a really good option, and I believe it's even called out within the IECC now for the U factor, is you can go into ASHRAE 90.1 Appendix A, and that will contain some of the assembly values, so you could be able to pluck those ones out. Those are already kind of that already deemed to comply numbers that you could very easily accept. Again, with this pathway, you're going to comply with R401 through R404, and you're going to have to do R408 also. The thermal envelope components, you're going to pay attention to table R402.1.2, and there is no report that's required to be provided for this particular compliance path. Now, let's see if we can make it work now. There we go. Now let's move on to the one that we probably are all incredibly familiar with. It would be ASHRAE 90.1 Appendix A. Sorry, I didn't mean to talk so fast. All right, let's talk about our R value option. Let me know if you need it again. The R value is actually the one that we're probably very familiar with. Again, it is that concept of what is the book telling us to do? That's what we're going to do. It's really very straightforward. And you're really going to follow everything that you find within the table R402.1.3. Now, whereas the U factor table, that's the maximum that you're going to do. When we go into the R value, that R value is going to be the minimum that you can do. Yes, I would be very happy. I'll send out a handout to everyone in the who's in attendance. Like I said, I'm at the airport, so just so you know, it won't be immediately. When I get done, I'm running to my gate to catch my plane. All right, let's talk about the R value concept. So basically, the table that we're going to be looking at, it has the components that we're looking at, it's the minimum R values, and ultimately, we cannot do anything less than what we find within this table. So here is the table, and just like the previous table, you'll notice that there were some changes that happened with it. And we also have, I was going to show you with my finger the lovely line, but I suppose I'll use my pointer here. We have insulation entirely above roof deck. Now, as you can see, that is incredibly important, because if we look here, our insulation R values went down from what they were in the 21. In the 21, it was required that R60. Well, they got reduced down back to that R49 in the 24. And it included that insulation entirely above roof deck. And you'll notice the insulation, if it's going into an attic cavity, something of that nature, it's a 49. Insulation entirely above roof deck is an R30. Now, the big difference is when we're doing an R30 and it's continuous insulation where it's not getting interrupted by framing members, you're getting a higher, more energy efficiency, I guess you could say, when it comes to that. And prior to the 24 here, if somebody was going to place insulation entirely above roof deck, they were going to have to go with the 49, even though it was going to be continuous. Not necessarily a bad thing when you consider the number one building component that has the biggest effect on your heating and cooling load calculations is your ceiling and roof. So it wasn't necessarily a bad thing, but it never took into account that idea of that continuous insulation. So as you see, a lot of the values did change, didn't change. We in climate zones 5 used to have a requirement for solar heat gain coefficient. It did get removed again in the 24. So really only the 21 is required to follow that solar heat gain coefficient requirement. All right. So one of the things that it tells you in 4021, it says, hey, you got to comply with section R402.2. So one of the things that I really want you to be aware of, especially in this particular compliance path, because it is the one time that the R value has built-in flexibility when you go into R402.2. And so you'll start to see this here. And here's an example of some of the flexibility that happens if you go with that R value option of the prescriptive path. If you have ceilings that have attics, and we're required to have an R49, if you can get an R38 up and over that top plate uncompressed, you get to reduce that 49 down to an R38. But again, this is only available for that R value option. Now, another option or flexibility built into this particular compliance path is if you have ceilings without attics, certain spaces like a bump out, like for instance, don't look at the horrible insulation job, but it's an example of a bump out that happens. The ceiling is without attic space. It's less than 20% or 500 square feet. And with that calculations, whichever is less, they're allowed to install only an R30 in it. So when we look at this particular pathway, again, we're looking at R401 through 404 and 48 are the sections we have to comply with. We do have to take a look at and utilize table R402.1.3, but you do have some flexibility in the section of R402.2 that we're required to follow, but the R value option does have the ability for some flexibility. There's no trade-off with this. Everything happens to be by the book and everything has to be on those plans. All right. Now, the third option we have within the prescriptive path is dealing with the component performance alternative. Now, this is where you get even more flexibility built into this particular option here. So what it does allow is it does allow for trading, but only for certain thermal envelope components. So in this particular concept, this is that twin building concept where you have the reference design that you want, your reference design, and then you have what you want within that structure itself. Now, everything is going to be based off what you find in table R402.1.2, and that's where all the calculations are going to come from. It also has new calculations that are involved with this. Now, this is the approach we probably see a lot of. This is our res check. You also could get a REM rate report that does the component performance alternative, and you can also get Ecotrope that will have the ability to demonstrate compliance with this particular pathway. So it's not only res check, but that's the one that we do see a lot because it's free software. All right, so now when it comes to the twin building concept, what you're going to do is we're going to take a look at what the reference design building is. That reference design building is going to put in place the values that you see within the table. It's going to have the U factor and it's going to have the F factor. Now, just to understand what the difference between the U factor and F factor is, U factor is the heat transfer going through an assembly, right? So from this side to this side, what is it? The F factor is actually dealing with the slab on grade. So instead of a U factor, you would get an F factor for that. And that's what the table refers to. And what you'll see down here, you'll see unheated slab and heated slab, the F factor, but it's still that somewhat similar concept. Now, what you're going to do for your, what you want to do in the building, the trading off that you're going to do is you're going to use whatever values that you're going to input. Now, when everything is said and done, as long as the proposed design demonstrates that the U factor and F factor is equal to or less than what the reference design is, it's considered to comply with the requirements that you find within the code. So in this one, everything again is still by the book. There is some trading allowed, but it is only permitted for that thermal envelope. You're going to comply with those sections that I'm hoping you guys all now can say with me, are 401 through 404 and 408. You do have some thermal envelope requirements that are going to be based off of section R402.1.5. So that's a section that you're now going to need to really pay attention to. It's not really crazy, but there are some things on there. Now, this is one that I threw in here about the manual J. When we start talking about all these different components kind of working, we want to ensure that one, our information or our values on the plans match what's on ResCheck, but they also should match what's on Manual J. And that's really important, even with choosing the compliance path and understanding the compliance path. So as I mentioned, ResCheck is a software that is commonly used because it is free, but you can also get a report from Ecotrope and you can also get a report from RemRate. And they do look significantly different, but if you have one of those, always feel free to reach out. We're happy to walk through those. So keep that in mind. Now, if you recall, we did talk about the fact that section 408 is required. And let me just take a step back for a moment. Does anybody have any questions concerning kind of the layout and breaking down what exactly the compliance path is for prescriptive and what the particular options are within the compliance path? And okay, we have one here. Okay, is closed cell spray foam under a roof deck considered continuous? I know that it is not continuous, something I heard, and are manual calcs required on all additions? That's a great question, Rebecca. And what I can tell you is closed cell spray foam under the roof deck is not considered to be continuous. Continuous has to be insulation without interruption of framing members. If you have it on the underside of that roof deck, you're going to have the roof trusses or the rafters and joists, whatever the case may be, that will be interrupting it. So it's not considered to be continuous. Now, some people say that you could say that when you are, dealing with, above roof deck, but above roof deck where it's not continuous is typically at penetrations around skylights, something of that nature, but it still is quote unquote continuous because there's no framing members that are interrupting that. I hope that helps, Rebecca. And as far as manual calculations required on all additions, if you are referring to the Manual J concept, oh yes, I'll be happy to go back to that. The Manual J concept with it, you may or may not, when it comes to additions, need to provide that. If you are putting in new equipment, then a manual J would be required to be provided. How it may be addressed is determining whether that existing equipment can actually handle the additional load of what an addition would have. Now, when we talk about additions, they do have to follow some requirements as far as a compliance path for those two. So typically how some locations have been dealing with additions and the manual J concept is if they get something on letterhead with the company and stamped that says, hey, no, the existing equipment can handle the additional loads of it, that's what they may do with that. I hope that helps. Okay, Reddick, let me go back there really quick. Okay, so the concept of this particular option here, and again, this is only if you're going with that R value prescriptive of the prescriptive path, so it's not across the board. What you're going to do is if you have a attic, and in that attic, you are required by code, right, to have an R49, you may have the ability to utilize only an R38 in that attic. But the caveat to be able to do that is that R38 has to be continuous all the way through up and over that top plate. And at that top plate, there can't be any compression that happens with it. So to have an R38, if I remember correctly, you have to have at least 12 inches or 14 inches. I can't remember now. One of the two as far as space so that it's uncompressed. So at that point, you're going to need to ensure that you have raised heel truss or those energy trusses that have the space in there that's going to allow that insulation to go up and over that top plate without getting compressed. Now, as far as having ceilings without attics, again, this is only for the R value option. Instead of doing that R49, for 20% or up to 500 square feet of your ceiling attic area or, rafter area, whichever is less, whichever has the least amount, you'll have the opportunity that you can install only an R30 for it, but it's only for that 500 square feet or 20% of the roof space. So in this instance, a bump out would be a great option. Maybe you have a little section that happens to be a cathedral ceiling, that those might be some areas that you would be able to install that R30. It can be bat insulation. It could also potentially be that continuous insulation. As far as up and over the top plates, you wouldn't necessarily be able to have continuous insulation because with the trusses or rafters that would be involved, that would be interrupting the insulation, so it wouldn't be considered to be continuous. I hope that helps. Any other questions before we jump into the fun called the additional efficiencies? Wonderful. All right. I am going to move us to, whoops, maybe I am. There we go. Okay. Let's talk about the additional efficiency requirements. So in the past, we used to have the option that we could pick one of these 5 options in the 21. We could do enhanced envelope, more efficient HVAC, or surface water heating, putting all of our ductwork inside the thermal envelope. Improved air sealing and efficient ventilation systems. Now, there's a lot more that's actually involved with this particular compliance path. Now, you have to get a number of points, and the number of points is dependent on the size of the house or the building. So if you are a building and you're up to 4,999 square feet of living space that's located above grade level, then you only have to get 10 points. If you are a building that's 5,000 square feet or greater, at that point, you will now have to get 15 points. Now that's 5,000 square feet of living space that's above the grade plane. of conditioned living space. You're going to then go into table R408.2. This is where you're going to pick out the credits that you want to incorporate into the project or that you have to verify within the project. And the correlating credits that you use has a section that tells you what the requirements are that you must meet to obtain those points. And you'll find that in sections R408.2. Now, as I mentioned before, we do have our 2s, our 3s, and our 4s that are involved with this. And what they're saying is that dwelling and sleeping units, for the points to be awarded, all of them have to meet whatever component that you choose. So you couldn't pick A and B and only a few dwelling units were going to go with A and the rest were going to go with B. You have to have all the dwelling units with A and all the dwelling units with B to get points for A and B. Does that make sense to everyone? Thumbs up, we're good? All right, Athena, did you have a question, or that was I'm good? All right, I'm going to take it as I'm good since it went down. All right, now here's the other thing. You can't, I wish I could do this. This is my aluminum for it, but integralization of credits, that's as close as I'm going to get, between measures are not permitted. So you can't kind of like do a part of this and a part of that one and be able to count it. You do have more options on how you're going to actually get there, which is you have 51 options. Now, not all of the options are available for all of the compliant or for all of the climate zones. And it's really based off that the point system is based off of the climate zone. It lets you know how many points you'll be able to achieve for these. So we're going to kind of fly through what the additional efficiency options that are available within here. We'll kind of talk about it a little bit further, but I just want to show you all the choices you have. Now, the first one here is demonstrating that you have a reduction in TC. Now, TC is talking about thermal conductance. So basically, you are now demonstrating the thermal bridging, thermal conductance that's part of the design. And if you're able to demonstrate that you're reduced by whatever percentage of it, then you get to count that as part of your additional efficiency. Thermal bridging became a part of the code. In the past, it was alluded to a little bit, kind of incorporated in some of the equations, but now there is a specific focus, I guess you could say, especially on the commercial side, as far as what thermal bridging and how to account for it. So that's part of what this section does. Oh, I'm curious, how do we educate all of these options to the public or create a handout to simplify the various options? Athena, that is a wonderful question. And I will tell you that this program knew that people were going to have this question. So that is on our list of technical documents we are putting together to illustrate and try to walk people through the various options for this. I hope that will help in all of your efforts. The other thing I can say is there's going to be a lot of training going on out there, especially for this section, because it is incredibly complex. And it's going to take probably a few times of hearing, you know, even if it was the exact same information, for it to all to kind of infiltrate through all the lovely parts of our brains to understand it. So I hope that helps. All right, so the next part is talking about some of the other items within the thermal envelope that you could improve upon, such as your vertical fenestration. Now, some things that it has to be noted is when we're talking about the thermal envelope, you can't trade, like if you went with the res check and you chose to trade something off, we'll say you're trading off windows that were supposed to be 0.28, and you traded them off for 0.32, To utilize this credit, you can't have anything less than what would be within that table. So you couldn't use that in this particular option. Is the reference home used in component performance the base for the TC? Yes. So I'll show you a slide on that, Erin. So hold that question, or I'll jump to that, or I'll answer that question here in just a moment. It's like you're reading my slides ahead of time. Here are some options as far as the mechanical equipment that could get utilized. Again, more mechanical equipment. You'll notice that we have high performance heating and cooling, ground source heat pump that you can get points for. When you start getting into gas appliances, high performance gas furnace option 1 and 2 will give you points. 3 through the other options as far as gas and cooling options in our climate zones will give you 0 points. So good, bad, or ugly, their reasoning behind this was fuel debiasing. And I'm not sure that necessarily equates, but that's part of why we don't see points for those particular options. But again, remember that even though you choose high performance heat pump with electric resistance, you can get points in climate zones you can't get points in the other climate zones. And it's with that electric resistance is where the part of the concerns is. Now we're going into a different section that's talking about high performance gas furnace and cooling options. You always have to look at the measures number over here. That's going to tell you what section, because if you notice this, if we look at R408.2.2 parentheses 11, it says high performance gas furnace and cooling options. But if we come back here, it says high performance gas furnace and cooling option, and they're different sections. So they have different criteria for it. And then we have more gas-fired water heater options, electric water heater options, solar water heating options, compact water heating distribution. That's where it's kind of paying attention to where you place your heating appliance and to where the fixtures are going to be. Your ductwork, if you have it all within conditioned space, you get some pretty good points out of it. If 80% of the ductwork is in conditioned space, it does change it. You have a reduction of your total duct leakage, because duct leakage is required now, no matter what, remember. You have some options if you install an ERV or an HRV. And if you install an ERV and an HRV and you have an air leakage rate of less than 2 air changes an hour, then you might qualify for this particular one. Now they have other options, because you may not choose to go with an ERV or an HRV. But if you utilize a balanced ventilation system, because there are other options out there, they're saying, okay, we'll give you that as an option, as opposed to using an ERV or an HRV. And then again, your air changes per hour is really going to be affecting how many points you could potentially get. In my opinion, this is a little risky to choose, because one slight thing could derail you from actually being able to meet this additional efficiency. And then we have energy efficient appliances. So dishwashers, washing machines, and dryers are ones that come into effect. Now, if you have on-site renewable energy measures included, you can get some points for that. Demand responsive thermostat, whole home lighting controls, and higher efficient lighting. For us, unfortunately, we don't really get that. Energy efficient appliances, all of them, or each of them? All of them. All right, so let's talk a little bit. We're going to go into these a little bit, not a deep dive, because obviously we don't have enough time to go into a deep dive. But our enhanced building envelope, it does say that you are going to comply with C402, or I'm sorry, R408.2.1.1 or 0.2, and then you have to take one of the measures, and then you have 408.213, 408.214. So if we look at 408.1 or 2.1, here's Aaron, this is the slide I wanted to talk to you about. Okay, so this is where you're going to do the total building thermal conductive. This is now being brought in and accounted to within res check. There's a requirement in there that you have to follow the equation. Now, this equation is equation 4.1, which is the TC subset P equal to or less than TC subset R, which is your thermal conductive of your proposed design and your thermal conductive of the reference design, basically showing that you're less than. You can have a reduction of any of these percentages, then you get to have the points for it. So res check now has a equation that's built into it, and with it being built into it, then you can utilize it. Now, the other thing is this also refers to R402.1.5. That is the section that governs the building component performance alternative option, which is where res check resides. So understand there is a correlation between this option of the additional efficiency packages and that particular product, or in that particular compliance path. Here is where I hope that helps, Aaron. Does that help? See, check. It's probably, quite honestly, when everything is said and done and all the things that are coming in, I think res check, while res check was utilized quite a bit in the past, I can see it probably going to get utilized a lot more because of these additional stuff. Improved fenestration. These are the numbers that you would have to meet. Again, it says all vertical fenestration have to be equal to or less than what the values are showing here. So as you can see, for climate zone 5, 6, and 7, our U factor would have to be a 0.25. So that means if you're going with res check, the one thing that you would not be able to trade off and use this as your one of your additional efficiency points, you couldn't trade off your windows. So there's a lot more, I want to say a lot more thinking involved with all of it. I threw this in there because this is one of the other options that you would need to be able to comply with. This is dealing with that solar roof reflectance. Now, this is only available for climate zone 0 through 2, so we're not going to get into it too much. Our reduced air leakage, this is basically saying, hey, you can't be more than 2. If you are in our climate zones, 2.5 if you're in 1 through 3. Or 0 through 2, sorry. You're doing this at 50 pascals. Now, we all understand that we do have another testing metric option when it comes to air change or the air leakage testing, which is the cubic feet per minute. Now, this is where you're going to find the value for that one. And this one is saying, okay, we understand you may not be going air changes per hour. You're going cubic feet per minute per square foot. And they gave a value for that, which is the 0.24. So it does account for both options. Now, our additional efficiency for our mechanical equipment, it does have very specific items that you have to follow as far as what you'll find within that. Improved air sealing and efficient ventilation options. So this is saying, okay, you have to meet one of the following. You either have to have an ERV or an HRV that's installed. Then you also have to demonstrate that you have air leakage rates that do not exceed what you see on the screen here. And then you also have the ability to do an ERV or an HRV or a balanced ventilation system. Now, if you're installing an ERV or an HRV, it does say that you have to have a sensible recovery efficiency that is not less than the 75% at 32 degrees Fahrenheit. And then you also, for the ERV, you have to have that latent recovery moisture transfer, and that has to show that it's not less than 50% at its lowest listed airflow. And then in climate zone 8, we care, but we don't care. There are some requirements if you're in climate zone 8. And so here's an example, right? So we're trying to do both of them here, but we have to verify that that mechanical or that HRV meets those requirements. So the sensible recovery efficiency at 32 degrees, and they said at its lowest CFM, it says that it's 68%. So this one is not meeting that 75%. So this is something that will have to be paid attention to ensure that we are getting the full aspects of this particular requirement. Energy efficiency appliances. It says that, you know, each appliance of its type that's listed in this table, and this is the table that's installed, then it has to meet the specific requirements to be considered as energy efficient appliances. Now, there is an exception for this particular one when you're talking about R2 occupancies. If a dishwasher isn't installed, then you have to have at least 2 appliances that comply with this. I hope that helps you, Tari, and I'm sorry if I am pronouncing your name incorrectly, but so basically all of them have to be there unless you happen to be in R2 and you're not installing dishwashers. At that point, then and then at that point, then you have the option that you have to then do the dishwasher and clothes dryer that meets that requirement. Ted has a question: will ResCheck recognize the option, or do you look for the percentage reduction? That is an excellent question, Ted, and I would have to say I have to play in ResCheck a little bit more to find out. I know in the past they have shown when you're going in there and you click one of the options, if you didn't meet that particular additional efficiency package, it wouldn't count it as you passed. So I don't have a very solid answer for you, Ted. But what I will do is at some point I'll have some time and I'm gonna jump in there and play in there, because I need to create some ResCheck reports under the 24 so that we can start creating some resources for everyone. So fingers crossed that will still be the case. All right. Okay. Great questions, everyone. With the point system based on square footage, is there a definition of what is considered below? Oh, yes. That is an excellent question, Erin. And absolutely, I did. I've been teaching the 24, and there are a lot of new definitions in there that you should be fully aware. There is a definition of what is now considered to be above grade plane. There is definition about what is considered to be conditioned space. There are quite a few there are quite a few what do I want to say, definitions that you probably are going to want to go ahead and take a look at. I didn't put definitions in here, but honestly, we could probably do an entire 1-hour webinar just on all the new definitions and what they're referring to on it. Do they get 1 point of an appliance that meets the table? No, they have to, what they have to do is for each of these items, they would have to meet it. So each item that's going to be installed has to meet the requirement of this table. So the refrigerator, the dishwasher, the clothes washer, and dryer would have to meet the requirements to get those points. So I hope that helps. As far as Denver goes, from my understanding, they are not adopting the 2024 IECC, or at least I haven't heard of any plans. They are working on with what they have as far as the 2021. I imagine at some point they will be moving. I just haven't heard anything. Are accessory building considered residential? Doesn't appear defined. When you say accessory building, Ted, what are you referring to? Are you referring to like an ADU? An ADU would be considered residential. If it was a storage shed that's going to house gardening equipment, that would probably be considered accessory dwelling unit and wouldn't necessarily fall into that. All righty, you guys are asking great questions. Oh no, I agree, Athena. It's not written really well, and I've had the conversation about it, and that was what the intent was. So that's the best I can tell you on it, that's for sure. All right, so now we're coming up towards the end. So renewable energy, demand response, single stage HVAC, variable capability and two-stage HVAC system controls, whole home lighting controls, higher efficient lighting, opaque walls. If you are in, here's one that like it's a little bit of a gimme. If we're in climate zones 4 and 5, so some of you get to listen to what I'm saying and appreciate it. Some of you will be like, ah, darn it, I'm in climate zone 6. But for opaque walls, if you're going to go with the U factor option, the insulation fenestration requirement of your for your option of the prescriptive compliance path, you have the ability that you could then, instead of that 0.045 U factor, you can have it increase to 0.060, but you do have to comply with at least one of the following. One is that your primary space heating is provided by a heat pump that meets one of the efficiencies of 408.2.2. You have an installed water heater that are heat pumps, and it meets the efficiencies of 408.2.3. And then you also have to get an additional number of credits, and you have to get 3 additional credits and renewable energy sources that would meet section 408.2.7. Oh. No, a detached building that is more like a heated commercial or bonus room. Once it's heated, I would say, if it's a heated bonus room, it falls under and it's part of the residential building, the residential structure, the single family home. At that point, what you're doing is it is considered residential. So if you have gas heat, you would still need a heat pump to be a dual fuel source. If you were going to utilize this particular option, then the answer would be yes. This is just one of those built-in flexibility items in there for climate zones 4 and 5, basically saying, hey, we'll let you have a little bit less efficient walls. But if you're going to have less efficient walls, you're going to do all these additional measures to get that option. And then whole house lighting control has, your stuff on there. We probably won't see it in the state of Colorado only because 408.2.9 isn't in the table. It is, but it isn't. I'll show you here just a moment. Okay, nobody get sick. Oops. It's not shown in the table because you don't get points for it. It's just kind of like a built-in flexibility for it. It's like, okay, we're going to let you do this. It's in this section, but to do this section, then you have to go and do all these other options that are in the table. the whole house, home lighting control, higher efficient lighting. So, yep. Thank you, everyone. We are at the very end. You should be getting a survey that pops up. Feel free to reach out to any of us if you have any further questions. Join us next week because we're going to do a deep dive into the performance path for the 24. And you are definitely going to not want to miss this because what I told you is basically everything that kind of stayed the same. The other paths really did change and they are a little bit more complex everywhere. So thank you, everyone. Appreciate it. Sorry about the technical difficulties Zoom is having, and hopefully next week things will work out a little bit better. So bye, everyone.